Hello everyone and welcome to a new Pandora FMS workshop. My name is Enrique, I'm a member of Pandora FMS Projects Department and today we are streaming from home, you know why. So excuse me if the sound is not the best or if the image goes wrong. We are going to wait a few more minutes before starting the workshop, so then more people can join. But by the moment, if you want, please confirm me in the chat if the sound is good. So, well, we'll start in 2 minutes. Hello again, it seems that more people has joined. Thanks Kevin for confirming that sound is perfect. And hello Bill in the chat. Well, for newcomers, let me introduce myself again. My name is Enrique, I'm a member of Pandora FMS Projects Department. And what we are going to talk about today is advanced remote monitoring. Well, in previous workshop we already talked about the basic features that Pandora has for remote monitoring. such as ICMP, SNMP, or TCP checks. And what we are going to explain today is the more powerful features. First, we are going to see how to run system commands remotely from Pandora using an SSH connection. Then we'll see how to do more elaborate checks using plugins that allow us to do some operations or concatenate tasks in different sources. After that, we'll explain a component that is called satellite server that is thought to monitor isolate networks using Pandora server characteristics, for example, network scans. And we'll finish with a short look to SNMP Traps and Pandora FMS discovery. Well, for that I prepare a little environment with two hosts that I have here, my SSH connections to them. One for Pandora server and the other one is for satellite server that we are going to explain. And as you can see, I already have some monitors in this environment where I have prepared for the explanations. Well, let's start with SSH modules. I'm calling them SSH modules because SSH is the most common protocol used to establish a connection to a device and run commands, but for some devices, for example the Windows host, it uses different connection methods. The idea is exactly the same. In any case, establish a connection and run a system command and get its output in a Pandora module. It's the same way that software agents work. Well, what we need to know first to start with this monitoring, as we do with the rest of Pandora modules, is to know what server is in charge of running this kind of modules. Okay. If we go to server management view, we have the different Pandora server features, the different functionalities a single Pandora server has. And here we can see the network server that is the one that manages the queue and the alerts for these kind of modules, as it does for ICMP, SNMP, or TCP checks, even if ICMP or SNMP has their specific servers. But for SSH modules are still run by network server. So to create one of these modules in any of our agents, we must select an option that says create a new network server module. I'm going to do it in my Pandora FMS remote here in the modules menu. And here in this selector, we must to check the create new network server module. Okay, this is the same for ICMP, SNMP, or TCP checks too. So the way we difference the kind of module is going to be created is in the module type. In this selector, we have different kind of data, two for ICMP, one is Boolean and the other is latency, to check if a host is alive or to check its latency. Some different data for TCP checks, others for SNMP, and finally the ones that says remote execution that are the module type for SSH modules. As you can see, the form changes each time I select a kingdom module, so I can configure it properly for any type. In my case, I'm going to do an example where I'm going to try to get the free memory bytes in my satellite server. So with this form, as you can see here, it's asking me for a command, so I need to know the command to get it. Well, in Linux systems, we know that the free command gives us all the information about the memory. And here, exactly here, what we can see is the data I want, is the free memory bytes. So what I need to do is to process this command And be sure that the output return is only this data. So I'm going to use some commands like grep to filter exactly the line where the data is, and this other command to get the specific column where the data is, in this case the third column. So I know with this command I can get the data I want. Well, I can copy it to my module, and I'm sure this will work in my Linux system. Another thing that will ask me is, of course, the target IP where I'm going to connect. When we create a network module, it by default gets the main IP address for the agent we are currently configuring, but if we know, we can set it as a different IP address. We can see here it also asks for a connection method. This connection method can be automatically chosen by Pandora server depending on our agent OS. If we set it to this option, inherited. So if it's set as a Windows server, it will use their specific methods for the connection, but with any other option it will use SSH. In my case, this agent is configured as a different than Windows OS. As you can see here, it's a satellite, so it will automatically use SSH, but I can also specify it, choosing it SSH or Windows Remote if I want that specific connection type. For me, this is a SSH protocol. As we can choose the protocol for the connection, we can also choose the port if our server or service is listening in a different port than 22. In my case, it's not necessary, as it's a standard installation. And the last thing I need to set to make this work is choose the credentials we are going to use in this connection. Well, these credentials need to be stored before in the Pandora FMS credentials menu that is located here in Profiles, Manage Agents group. Here, up in the right, the credential store menu. And here we can store different keys for different tasks that Pandora can do. In my case, that is a user and password based key. I'm going to choose the product as a custom. The identifier is the name I want for these credentials. I set to Pandora, and the user and his password. Okay, as I already have it registered, I'm not going to register it again. I have it here, and when I have it, I can choose them in my drop down. Well, with these parameters, we already have the connection configured and the command we want to run. So we must be sure that the module type we have chosen it's the same than the data we are going to collect. In this case, I know this is a numeric data, as it's the bytes free in the system, the memory bytes free. But if, for example, I want to monitor something like the last user that have login, it could be an string data, well, alphanumeric data. And if I want to get the if a process is running, for example, I need to choose it as a Boolean data. In my case, it's numeric, so I set it to numeric data and give a name to the module. Okay, with this configuration, I hit the create button. So after a while, after some seconds, a network server will queue this module and will run it. So we will see it, as you can see here, initialize and with a data. So if I go to the agent view, I'll be able to see my module with the last data that it has collected. In the server side, we have some configuration parameters that are important to mention. If we edit the etc pandora server.conf file, we'll find some parameters. For example, network threads. Well, as remote execution modules that I'm calling SSH modules are run by network server, they are managed by its network threads. So I can set here how many parallel executions I want my Pandora server to do. So if I set it to 4, then my network server will be able to run 4 parallel remote modules execution if I only create this type of modules. And another important parameter here is rcmd timeout. Here where we can set the timeout for the remote execution modules. It's important to know that this timeout it's applied to close the remote connection. It means that if we don't control the timeout in the module command itself, it will happen that connection gets closed but command process keeps running. This is not due to how Pandora server works, it's caused due to how SSH protocol works. And we know it because we've realized that with some commands, even if connection get close, they keep running. So take care of that. If you configure a complex command with loops or something similar, be sure that the command itself is able to finish its execution. Okay? Because this timeout will be applied only for the connection. We cannot assure that commands will be finished. And that's all for remote execution commands. As you can see, it's very easy, and it's a powerful method that it's a good alternative for an agentless monitoring. If we can't install a software agent in any device, we can run this kind of commands, establish a remote connection, and get the data with the system commands. Well, let's go with the plugin server modules now. As I already mentioned, plugins allow us to do more elaborate checks. For example, get the data from a database, push it to a web page, and get the HTTP code error. So with plugin server modules, we can do that kind of things. To make it work, there are 2 requirements. First, be sure that plugin returns a single value, and the second is register plugin execution in the Pandora console. Some plugins are already registered in Pandora FMS. Here you can see them, and here I have one that I registered that is called Dynamic SNMP. Sorry. It's a plugin that allows you to generate several modules via SNMP, getting modules name from a branch and modules values from another branch in the same SNMP table. Okay, as you can see, it's something a little bit complex, so a plugin is the best alternative to do it. Okay, if I go to the plugin configuration, you can see I've given it a name to identify it in Pandora, and I've set the plugin execution and its parameters. Okay, in the parameters, all the variable modifiers are set as the macros field. As you can see here, field 2, field 3, and field 1, and that are defined here in the bottom of the form. So these parameters, I'll be able to edit them in the module configuration, but it's something we are going to see now. For each one, we have a description that allows me to identify what I have to set here in this variable. Default value, if I want to set any, and I can set it also help a more extensive description if I need to explain better what is that. In this case, as they are very simple parameters, are host, SNMP version, and SNMP community, I don't need that kind of explanations. We have also this field that says height value that converts the field in a password type if I need to pass some hidden data in the form. We're going to see it now. I also have another macros in the configuration to use the module's agent name, and this one to set the main IP address of the agent. But this is for me because it's easier for me with this configuration. You don't need to specify agent macros. With field macros, it's enough. So with the plugin register, we can start using it. I'll go to my agent. I have one ready for this. This agent to the modules menu. And as we did with the other module that we set it as a network server module, as this one is going to be run by plugin server, I need to set it as a create a new plugin server module. Here the form is also the same than the other we set for the SSH module, but you can see here a drop down that says plugin, where we can select the plugin we want to use. Okay, we can find here the different plugins we have registered in our Pandora console, and I can find my dynamic SNMP plugin. And as you can see, here the form changes and shows me the fields that I have registered in the plugin. My first field, that was the host, the SNMP version was the second field, and SNMP community for the third field. Okay, and with the default values I set. As here is set with the macro address, it will take the main IP address of the agent, but if I want, I can also change it. Okay, so with this configuration is enough for me, as I don't need more parameters. What I need to do is, as in the other case, know the module type that will be returned by this execution. In this case, the dynamic SNMP plugin generates several modules, but the execution itself returns a number, returns the number of modules that have been generated. So I know that the module type will be a numeric, generic numeric in this case, and set a module name to complete its creation. I already have it created here in the same agent. This execution that it says the dynamic SNMP. As you can see here, it is exactly the same configuration I was setting here. So I'm not going to create again. And as I mentioned, this plugin generates several modules that you can see here. Okay, with the default configuration, it generates the default interface monitoring modules that are if operator status, if out octets, and in octets for each network interface. And as you can see here, if I force the dynamic SNMP plugin execution, it will also refresh the last contact for the other modules. Okay, you can see here now. Okay, my plugin has been run 7 seconds ago, and the rest of the modules have been processed 4 seconds ago. As you can see here, it says that have been generated 6 modules that I have here. So as we mentioned, is something more elaborated than just get a data remotely from a device. Okay. Of course, there are plugins for many different tasks. This is not the only way to use them. So I recommend to take a look in our Pandora FMS library if you're interested in something specific, and you'll probably find the plugin that will work for you. Okay, let's go with our third block, that it's a satellite server. I said it's thought to monitor isolated networks, and it comes with many of the Pandora server features and some specific for itself. For example, one of its features is that it's a server that don't need to establish a connection with the Pandora FMS database. It means that any of the configurations done in the web interface, as we have been doing now, and that are stored in the database, are invisible for satellite server. So all the configurations must be set in files that are located on the server. This is an enterprise component, and to make it work, we need a token to be established in the satellite. Sorry, in the Pandora license that says satellite enable. So if you already have it, you should know that there can be as many satellite servers as you need with the same license. Okay, there's no limit. We can have only one satellite, or 5 or 10, or as many you need. To install it, you can download the installation package from the Artica support web page. I have this package here. And the process is very easy. It's also the same process to install the satellite server and to update it. I already have it inside, but I'm going to show you how it works. First, we need to unpack the files that are here. Locate ourselves in the satellite server folder that has been generated, and here we'll find this script that is an installer. Just run it with the install option, and it will install the satellite server in our host. As I say, it's the same process to install or to update. Well, as you see, it's easy too. It's just 3 steps to make it. And as I mentioned, satellite doesn't have a connection with the Pandora FMS database, so I need to specify the Pandora license as an enterprise component to make it work. Well, the license must be set in its configuration file, that it's etc Pandora satellite server conf. In this parameter that says Pandora license, we need to copy the license from our console, this text, and paste it here. Okay, so with this we'll be able to make it run. We need also to specify the server IP where we are going to connect, as satellite server connects with Pandora FMS server. In my case, I'm going to change it to my IP address for my Pandora server. And another parameter that we should set, that it's established by default, is remote configuration set to 1. So we'll be able to edit this configuration file from Pandora console. We are going to see it now. Well, with this configuration, I can start my service. In my case, it was already running, but I'm restarting it. Uh, okay, one moment please. Let me check its configuration from here. As it was already working, I need to edit its configuration from here. Okay, it's this one. You can check the logs too, to check what is going wrong. It says invalid license. Okay, one moment please. One moment, I'm editing it. And okay, okay, it's ready. It will be running now if I restart it. Okay, it's running now. Okay, I miscopy one of the characters in the license. So with that configuration, we'll be able to see our satellite server in the manage servers view. You can see it here. It will start reporting in a few seconds. And with the remote configuration parameter, we said, well, that it's already set by default. You already see it. We can edit the configuration file for the satellite server from here with this button that says remote configuration. We are not really editing the file that is located in our satellite server. What we are doing is modify a copy that it's located in Pandora server. So satellite downloads that copy each time it finds that has changed, and the impression is that we are editing the file that it's located in that host, but it's not real. Okay, what we are editing is a copy, and satellite downloads it. Okay, so as we have the satellite working and start, you should see it reporting here. Okay, as you can see, it's reporting. What we need to do is create agents for this satellite server and start monitoring our devices. As all the configuration is set into files, we need a configuration file for each agent that it's monitored by satellite server. And there are three ways to do that. We can create the files manually in its configuration files folder. We're going to see it here. The satellite agents configuration site folder is located in etc pandora.conf here. And we just need to create a new file. I'm going to call it test.conf and set two parameters in this configuration file. The first one is an agent name, and the second one is an IP address. Okay, with these two parameters in the configuration file, satellite server will start reading in this folder, will process this file. You'll see it will also change the file name. I'm going to restart satellite server so you can see it. Okay, As you can see, the file I created, satellite has changed his name. It's an MD5, has MD5 of its name, and satellite will start working and will report this agent to my Pandora FMS server. So I'll be able to see it here in my manage agents view in a few seconds. This is the first way to create an agent in satellite. It's not the easier, as you need to establish a connection to the satellite server host. We're going to see the second one that with some configurations we'll be able to do it from Pandora console. The second way to create agents is by reading a host file. We are going to see a good way to configure it with other Pandora features. We here in the Pandora console, in the configuration menu, collections, we have created a collection that is called satellite host. Each time we create a collection, we need to establish two parameters. The first one is a name for this collection, so I can locate it here, and a short name that will be used as a folder name for the files we are going to upload here. So as it will be a folder name, it's a recommendation not to use blank spaces or any strange characters on its name. Okay, just establish a single word or something like that. In my case, I create my collection with the short name satellite, so it will create a folder that will be called satellite. And here in the files menu, I'm able to upload or create files for my collection. In my case, I've created a file that it's called satellite host txt that I'm able to edit from here, from Pandora console. Okay, and in this file, I'm going to set the IP address and the agent name for the agents I want a satellite server to create. Okay, in my case, is this IP address, and the name is Toshiba. That is the name of the host. So with this configure, once we have finished editing the files, we need to apply changes. And now what we are going to do is to transfer these files using Pandora to the agent that I have installed in my satellite server. Okay, I have both services running, the satellite servers running and the Pandora FMS software agent service, and I have also the agent registered here in my Pandora console. So to transfer the file, what I need to do is go to the agent. In this case, it's satellite, to the configuration menu, collection, and here add the collection I created. Okay, so I've added the collection to this Pandora agent. Let's see what will happen. In this folder, etc Pandora collections, we can see it's empty. It's an empty folder. I'm going to restart Pandora Agent service to force its execution. So with this, Pandora Agent has read its configuration file. It can see that there is a collection that must download, and he will download all the files that are located in my Pandora server. Okay, and it will download it in a folder that will be called satellite as the short name I set to the collection. And if I see here in the satellite folder, I can see my satellite host, and I can also see the content that I set in my Pandora console, that was my IP address and my host name. So what I need to do now that I can transfer this file to my satellite server and I can edit it from my Pandora console is set to the satellite configuration where is that file located and force satellite server to read it. So I'm going to satellite configuration and I look for a host file parameter and set here the file location. Okay, you can see it's exactly the same location where this file is transferred in etc Pandora collections satellite host txt. And I need also to establish a recon interval. So it's 300 seconds in this case. Satellite server will read that file and will try to create the agents to start their monitoring. It will only create the agents if their IP address it's alive. Okay, if it finds that ping works, okay, then the agent will be created. If it doesn't respond, then the agent won't be created. So with this configuration, satellite on its interval will do that. I'm going to restart it to force. We are going to see that some of the agents we already said has been created. Router agent that I created manually, and Toshiba 2 that is the agent we have set right now. And the third way to create agents is the easiest, as it doesn't need this kind of configurations. It's just say to satellite server a network to scan. So satellite server will try to find the host app in that network and will create a different agent for its device. This is in the satellite configuration file. With the parameter recon task, where we can set the network address that we want to scan. In my case, this is my local network, and we need also to enable here in this parameter the network scans. Okay, if I set it to 1, its recon interval it's 300 seconds, 5 minutes. Satellite server will try to scan all the network and will create all the agents that are up and running. And by default, satellite will add some specific modules that are host alive and host latency. We'll see it right now. So I'm going to update its configuration, restart again to force it. And satellite will start creating my agents. We can see it in the log. Okay, here it will appear that let's do it with more lines. Okay, here you can see that it found that this host already exists, so it's not going to create it, and it will start some network scans. Let it go for a while, and we can see the modules that we can set for satellite server. Okay, now that I have some agents, I can see the configuration for the satellite modules. Well, it's the third time I say this, but satellite doesn't have connection to Pandora FMS database, and all configuration has to be done in configuration files. As each agent have a single configuration file, the modules we want to be monitored in that agent from satellite server must be set there. We can see the examples here for Toshiba, for example, its configuration file. We can see the agent name and the address and other parameters that are set by default with the server. And here there are the configuration of two modules. The first one is called ping, and the second one is called latency. Satellite server has its specific modules, and its specific module have a specific configuration, but they are very similar to the software agents configuration for modules. Okay, with these tags, module begin and module end, and in the middle of those tags, we have to set the parameters, the name, the name, the type, the type of execution, etc. There are many types, so I recommend you to take a look in our wiki and know more about how to configure them. We are going to do some examples here, but not all of them. And to create modules in the satellite agents, there are different utilities we can use. For example, configuration policies in the console, where we can set a kind of templates for very similar agents, where we set the configuration in one place, and we just apply it to our agents. For example, this basic Windows monitoring has some modules already configured here. As we can see, they have their configuration. And what we can do is select the agents that we want to apply to this policy. And just apply the changes. So those agents will have these modules. And another way to create modules easily in our agents, it's using the agents wizards. Agents wizards were thought to work with network modules, but they are also compatible with satellite modules. For example, the SNMP interface wizard that allow me to scan using SNMP protocol a device. In this case, I'm going to do it to IP 101. Sorry, I need to specify here that it's going to be run by satellite server. So my satellite server that is set here will scan the device and will return me the information that has found for this device. In this case, the network interfaces. So here I can get the modules I want to create, the most commonly used, if operator status, if in octets, and if out octets, and here if out octets. And I can create these modules in my satellite agent. You can see the modules that has been created here. Okay, and if we see the remote configuration file, we can see the configuration set for this agent. So satellite will run this test too. But to make this work, to make this wizard work from satellite, we need to configure a specific feature for servers that it's called exec server. We can find it here if we edit the configuration of satellite, nor its configuration file. We need to do some steps sharing SSH keys. So I'm not going to explain here in this video, but you can see all the steps in our wiki. But here you need to enable the execute server, and here you have a token that allows you to see if it works or not. In my case, it's working, and that's the reason I was able to make the wizard work with my satellite server. So we have seen how to install the satellite server, how to create agents to start monitoring, and some methods to add modules to these agents. Let's take a look in some important configuration parameters. So that will allow us to understand better how satellite works. And after that, we'll take the look in SNMP Traps and Discovery Server, and we'll end the video. Well, Satellite Server it's a powerful tool to monitor many devices in big blocks. Okay, using big blocks of monitors, and it also divides the executions in different threads depending of the kind of monitor that it's going to run. So it have specific threads for ping modules, specific threads for latency, specifics for SNMP, TCP, WMI for Windows devices, and different intervals for each kind of monitor. So we can have a configuration where ping monitors are run each 120 seconds, but plugins are run each 300 seconds, for example. Okay, this is because it allows us to find errors more frequently. For ping, for example, if we are pinging our devices, it's 120 seconds, but sending the information to our Pandora server, it's 300 seconds. That is the conf interval. Or sorry, it's not the conf interval, it's the agent interval. We are going to have a new different data if 5 minutes, but we'll be able to find errors more frequently. It's 120 seconds, 2 minutes. So we keep the regular working of monitors with the interval that we can see in the remote monitors with network server, for example, but find the errors faster than the Pandora server does. Other parameters important are threads, as I already mentioned. We have threads to send the agent's information. We have threads for each kind of module: latency, ping, plugin, SSH, SNMP. Okay, for any kind of monitor. And it also have some specific binaries to make this work faster. For example, fping. Okay, fping binary that is faster than using ping, because it allows to run pings in blocks and receive the answers at the same time. That kind of configurations. And that's all for satellite server. That's all I have prepared here. Let's take a look on SNMP Traps and Discovery. Okay. A part of the features we have been seeing in this video, Pandora server is also able to collect SNMP traps and show them in the Pandora console and fire alerts based on their content. For that, we need to enable the SNMP trap server or SNMP console that I have enabled here in the Pandora server configuration file. And we can test it with a command in the system. I'm going to send a trap. One moment. Traps can be seen here in the monitoring SNMP console. Here we will be able to see the traps reside. So here in terminal, with this command, I can send a trap to my Pandora server. It's sending to himself. It's a fake trap, okay, as I'm setting OIDs as 1, 2, 3, 4, 5, 6. It's just for the test. But if I send it, as I have the SNMP console running, I'll be able to see this trap here in this view. When it get processed, here it is. Okay. If the trap is sent from an IP address that is assigned to any agent in Pandora, as is this case, it will appear here with the agent name instead of the IP address. Okay, and it also allows me to click and go to the specific agent to see its configuration and modules. And if we want, we can also add MIPS or custom translations for SNMP OIDs to make them more human readable, we can say. Okay, in this case, I can see 2, 3, 4, 5, 6 that it's not very useful for me and also for the trap information. But if I go here with the SNMP Trap editor, I can set a specific text for my OID. So I can see it here with test trap, create my translation, and the next time if I send exactly the same trap, it will appear here with my text, the text I set. In this case, the test trap. Okay, it's only applied to the new traps. Okay, the traps that are already registered are with the numbers, but it's very useful to find the information faster. And with these traps, we can also fire alerts. I mentioned if we specify that a trap that comes from a specific IP address or SNMP traps that comes with a specific content. For example, the test trap string on its content. And to finish the video, I just wanted to mention the capabilities of our discovery server. Well, discovery server is a component that allow us to run periodically tasks such as send a report by email, run a network recon task, and monitor the most commonly used application or services. And do it just filling a form with the needed data, and the discovery server will automatically monitor our application and generate agent and modules. For example, in applications, you can see here some for databases or virtualization, MySQL, Oracle, VMware, SAP, and here we just need to fill the form with the connection data, and Pandora server will do all the job. The intention is that this is very similar to the dynamic SNMP plugin we saw, and the intention is that eventually all the plugins we have in our library could be configured from here and make it easier, but by the moment there are a few of them, and of course library plugins can be still used with Pandora. There is also a specific menu for the module library here, where you can see the upload models. Well, that's all for today's video. Thank you very much for being there. And as it said here in YouTube, remember to hit the like button if you like the video, share it, and subscribe for more. Bye.